Get it? You can pause. Pick your flavor.
Thank you.
Okay, the difference. The scatter plot is going to be on your calculator. You do not have to make it on your paper. I want you to make the line of best fit and use it to answer those questions. You do not actually have to make the full scatter plot on your paper. So we spent 2 days playing with it. You tell me what the line of best fit is, following these instructions. Use that equation to answer the question for part C. I want to know what you know, not what your neighbor knows. Please. If it's in there on your papers, you're good. Anyone? All there? All there or hopelessly lost and maybe regretting not asking anything in the last 72 hours? Okay. Oh no, someone else was playing with the calculator. I need to reset it. Second plus 7, enter 2. Clears out all memory, starts it over. I got data. What do I do to put data into calculator to make perfect thing? Stat. Come on, Frank. Hit it. Frank. And start typing. Does it start at 2004? Oh, hey, cool. Okay. Making sure my table is here and there's not a data point to the other side. Down here it says number of years since 2003, so I'm not writing 2004. I'm writing 1, 2, 3. Come on, Frank. 4. Come on, Frank. 5. Right? 1, 2, 3. That's it? Okay. Head over to list 2, 15, 82. Come on, you piece of 1, 5, 8, 2. There's 6 of them? Okay. 1992, 1635. The fact that it's even working this well is miraculous, given last hour it completely dumped again. 1745 and 1801. If I tried to do stuff right now and oops, come on. Okay. If I tried right now to make a line out of this or do a stat plot, it's missing a value. So it would say error, dimension mismatch. I want you to remember that. If you ever get an error, it's going to tell you why it's wrong. It's not just going to say quit your life. Okay? It's going to tell you why it's wrong. So yes, I do need another point over there, 6. Okay, you got a bunch of data and make a line. Now, all I needed was the line. Stat, calculate, linear regression. We wrote down the steps. The steps are on our notes in the holy sheet. There's 2, 3 videos of us doing this now. Lots of places. On 84, I have the privilege of being able to say alpha trace, and it'll just bring up a shortcut menu of where I want to put stuff. If I'm not on a 84, it's just going to say linreg ax plus b blink, 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 blink. To plug it in, we'd have to say variables, the y's, the function, and then you choose which one you want to plug it into. Okay. Now the reason I do this is because now it's going to take whatever I get for my regression model and it's going to plug it into Y1 for me with the full decimal train on there. I won't lose anything. It's great. So part A, all I wanted was put the stuff in the calculator. Part B, write the equation that represents the line of best fit. Y is, well, I suppose Y is about 42.11x plus 1545.93. Part C. Part C says, use your model to estimate the enrollment in 2015. How many years after 2003 is 2015? 12. Okay. So I can either take these numbers, I'm going to store them. Okay. And now if I use, I don't think I showed this or not. I can now right above store is recall. And I can recall what, say, A is. Should work, right? No? All right, it's been a long time since I used that feature on here because we never use it. Instead, once it's stored, it's already in y equals. Well, Frank. I can either head over to the graph and trace it out to 12, assuming that my window is big enough. Or I can go to second table. And if you want to scroll down to 12, you can do that as well. But we found that the easiest way was change your table over to independent variable x's is an ask feature. Meaning I can now say whatever I want, and it's going to tell me the answer. So you can manually type it in, you can trace it on the graph, you can use the ask feature, whatever you're going to do, you're going to plug in a 12 for x, and it's going to tell you. Oh, also, these cells are only so big. If I go over and highlight it, see that there's a lot more to the decimal train. Okay. So I would say that the enrollment was about 2,051 students. Okay. So you should only really have two things written on your paper. Most of this was Calculator Mojo because that's what we were learning. So I'm going to say, did you get your data plugged in correctly? Meaning you went 1, 2, 3, 4, 5, 6. Plugged in data correctly. Second point, did you even find where the calculate feature was? Did you calculate the correct value? Did you get the correct model? Did you press the buttons, look at the graph, input manually? Did you pick one of those three methods to get the correct answer for C? Okay, so I can put things in. I know where the calculate feature is. I know how to press buttons to get my answer. There's 3 points. 3 points of this is just, do you know how to run the calculator after 2 days of running the calculator? The other two are the correct answers. And those are simply, if I press the right buttons, there it is. Okay? We are going to use the regression feature multiple times throughout the semester. You need to know how it's done. That quicker video, that like 10-minute one, that just, it's old. It's like 4 or 5 years old. I think I did that on an old laptop without even, like, just hit screen record. That video, that'd be a pretty good one to bookmark or something for when we come back and do quadratic, cubic, quartic regression, logistic regression, do radicals, do sinusoidal. Like, as you move through math, you're going to keep coming back to regression. You got a button on your calculator that says, find me an equation from a table. And it's going to do lots of cool stuff. Basically, if you have a table and you know what different graphs look like, you never need to make the equation manually again. It's just going to do it for you. So The homework. Again, 72 hours. The only question I had was someone saying, do I really have to make the graph on number 8? Like, yeah, it says make a graph. If I remember right, there were 4 questions. One of them was make the graph. The other 3 were just make the trend line and find answer. That's it. Okay. The reason that we have to know how to make the graph is because that was one of the things that we were actually reviewing. How do I make a graph with an appropriate scale and labels? I hope we know how to do it. It's number 5 on your quiz. So, anything from the homework? Okay. Before I go handing out the review, which has the quiz on the back, if you would please, all the devices go over here. Try to put them all in one area. I'm going to be filling up the counter with pre-calc books while you guys are doing your quiz. Okay, that's phones, smartwatches. I don't think anyone here has got Google Glass. Okay. All good? Okay. Then, Algebra 2, 2, 3, 4. 1, 2, 3. 1. 2 for you. There's a thing. 1 for you. 1 for you. Trade you. Don't give me that look. I had 2 in one hand and she had 1. It was a perfect trade. He gave a stink face. 1, 2, 3. Okay, I can count. I swear. Everyone got one? Did you bother handing them down?
Can I have one, maybe? Can I have one, maybe? You guys want a couple? I got a couple for you. Don't worry about it.
Everyone got one?
Yeah, now we do.
Okay. Then, some review. First things first, we finished off direct variation, then we moved into a bunch of stuff that had to deal with slope-intercept, point slope, and standard form. Direct variation. Oh yeah, we got fractions. Direct variation says y can be represented as some constant of variation times x. So if I divide, that constant of variation is y over x. Meaning, if I know that y varies directly with x, then I can say y over x equals y over x for everything in this relation. So when they say y varies directly with x and y is 3/5 when x is negative 4/3, then it should equal another y and x. Be careful, I hear those are expensive. So they say y is 9/16. We said y over x, please do y over x. Find x. Jesus fish. Multiply the 2 that line up, divide by the 1 that doesn't. Don't overthink this. multiplying fractions. So I've got 9/16 times -4/3 divided by the one that doesn't line up, 3/5. Well, dividing by fractions is easy as pie. Okay, just because it's got fractions in it, don't freak out. Because look at what happens. Cancel, cancel. Cancel 1, cancel 4. Y'all remember how fractions work, right? Cross-canceling? I hope we remember how fractions work. Okay. And then, straight across, 9 times -1 times 1. What? Did I say? Oh. Boo. All right. I'm going to reorient Frank then. I was trying to work through it. This is why I say like homework assignments are supposed to be distraction free. Frank was writing like 3/4 of an inch off to the side of everything I was doing. And it made me do the dumb. So let's try that again. 9/16 times -4/3 times when I divide by 5/3. There we go. That's better? Okay. So I'm going to say 3 and 3 is 9, with 9 is 1. Right? 9 over 9 is 1. And 4/16 is 1/4. So if I multiply straight across, I get -5/4. If you try to, but it's a compound fraction, I need to like make it into a regular fraction, and then you're gonna fight with it for a while. But if you just go with it, just go with it. This times a reciprocal of that. It's so much easier. Okay. So the idea behind this is whatever numbers I give you, you can set up y over x equals y over x. It could be a word problem talking about for every shrunken head, there are this many voodoo monkeys. I don't know. Like, as long as you're comparing same thing to same thing. Do y'all remember doing a, probably, and then stick figure Steve over here, and you'd say, the tree's shadow is this long, and then Steve's shadow is this long. Y'all remember that kind of stuff? It was super easy. You just said height over shadow equals height over shadow. Jesus fish. That's it. You would just set up a ratio, multiply the two that line up, divide by the one that doesn't. Poof, done. Okay? Randomly, I got to ask because I'm hearing like more and more things about middle school and geometry that says we're not doing middle school and geometry. Did you ever make a clinometer?
Yes.
Okay, clinometer is, no, not you. You. Okay, you take a protractor and you would tape like a straw or something on it. You'd hang a weight down from it, like a washer on a string or something, and then you can look up or down and it will always hang at whatever your degree of elevation or degree of depression is.
Yeah, we did that.
So you would literally measure the length of your shadow, the length of the tree's shadow, and then you would go up to the tree and do this, and then you would know what the angle is in the corner.
We did that on paper. We did that
Oh,
on paper, but we didn't.
okay. It's super easy. Okay, you ever see like a survey crew next to a construction site? They got a little tripod and the dude's got a little orange camera there. right? He's doing basic trig. Okay? They're using a clinometer, just a fancier one, to measure angles of elevation and depression, and then they use basic trig to find out, well, if this is this much higher, I need this grade on, we're going to backfill all the dirt. I need this much. Ever? No? Dang. Y'all got robbed. Okay. Part 2. Write an equation in slope-intercept form of a line that passes through these 2 points. So what does slope-intercept form look like before I even start? Okay. So at the end of the day, I need that. How do I get that from a pair of points? Slope first. Maybe I should write down slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Which means I will write a bunch of parentheses. If you need to label x1, y1, x2, y2, do it. Because then it's just plug and chug. This number goes here, that number goes there. Why is it important to use those parentheses even if you don't want to? Those negatives. How many times have I seen the kids say 7 minus 11? And they assume, well, the negative's already there, so they just put it there for me. They're nice like that. Math ain't nice. Math doesn't care. It's almost like a virus. It doesn't care what you think. It's just going to do its thing. That's a negative 11. Okay? And then, negative 4 minus 2, getting a positive 18 over a negative 6 is a negative 3. Cool. I got a slope. I got some points. Okay? Now you got choices. The way that we were doing it, and the way most modern textbooks will do it, is y minus y1 is m by x minus x1. And I'll plug in a y1, I'll plug in a m, I'll plug in a x minus x1. And I'll take some points in there, like, well, which one do you want to use?
2.
Ooh. I'm going to go with the second one. I heard second one, and I like second one, so I'm going to do it. 7, negative 3, and negative 4. Aren't they both right? It doesn't matter. At the end, you should get the same answer. So I remember that minus a negative, because I used my parentheses, is really add the opposite. I'll disturb it. Y minus 7 is negative 3x minus 12. Add the 7 over and get negative 3x minus 5. That's a way. I never really talked about this, but did anyone have a teacher who showed them like 1991 way, which was if I have y equals mx plus b, plug in a y, plug in a m, plug in a x, go and find what the b is.
Oh, that looks way easy.
So here's the reason that a lot of modern classes and textbooks don't do that. We have a tendency to see b equals number and think we're done. You found b. You need to take m and b to write the equation. There's a lot of kids who would use this to find b, and yeah, it's nice and simple, but then you'd think you're done. And you just quit without actually having the equation. But if I do it with point slope form, it's all there. I'm just rearranging it. Okay, so one is like some assembly required. The other is it's already done, but it costs more, right? Like, you got your choice of which one you'd like. Oh, reading the problem explains the problem.
Identify the slope of the line.
Please make sure you say the slope is -3, the y-intercept is at 0, -5. Okay, reading the problem explains the problem. In fact, that'd be a good thing to just always, when we go through the review right before the quiz, that would be a pretty good thing to write down, is number 2, big old letters next to it, answer the question, right slope and intercept. Like equation, slope, y-intercept. Make sure I have all 3. Because you don't want to get the lame points off just because we forgot to read the problem. Okay. Same thing, except this time we're headed to standard form. So I still have to go, slope is y2 minus y1 over x2 minus x1. Label x1, y1, x2, y2. Say 8 minus a -5, 2 minus a 10 is a 13 eighths, and I'll put the negative out front. I got a slope. Yay. Y minus y1 is m by x minus x1. It's all plug and chug stuff. Okay, I got a slope, -13 eighths. I've got an x and a y. I'm going to use 2, 8 just because they're both positive. I disturb it. Say y minus 8 is -13 eighths x plus 26 eighths is 13 fourths. Ew, fractions. Before I go moving things, y'all notice we're going to have to go to integer coefficients anyway. So you can choose to move things right now with fractions in play. Or you can get rid of the fractions now and then move things around. Your choice. Don't matter. Most kids would rather not work with fractions if we don't have to. So what do you multiply the whole thing by to get rid of all the denominators? Well, whatever the least common multiple is of 8 and 4. 8, right? Because 4 goes into 8. Okay, no. If you multiplied the whole thing by 32, would you be wrong? You would just have a larger scaled answer than what I have on my paper. I'd look at it and be like, damn, those are big. Okay, hold on. 10 to 5. Oh, okay, you just did that. Gotcha. You're good. And I'd move on with my life because you're right. So if I take the whole thing by 8, we got 8y minus 64 is -13x plus, careful, 26. Right? Because 4 and 8 reduces to 2 over 1. Okay, now I want standard form. What does standard form look like again? ax plus by equals c. So I'm almost there. I'm going to add 13x over and add 64 over is 90. Cool, I did it. Move on to the next problem. Reading the problem explains the problem. The x and the y intercepts. Remember the nice little trick to doing that once it's in standard form? Put a 0 in for one or the other. If I put a 0 in for x, 90 over 8 and reduce it. So what's that, just 45 fourths? or 11.25 since it's a terminating decimal. If it's a terminating decimal, get in the habit of just working with the fractions. If I put a 0 in for y, I've got 13x equals 90, and I'll divide, and unfortunately that just stays butt ugly. Okay. So the intercepts aren't pretty, but I found them. Okay, if I need to write that out, remember over here we also said that the x-intercept was always going to be c over b. We said that the y-intercept was always going to be c over a, because a by 0 plus by. Like that. Like if I actually put the 0 into the form of the equation, I can get these nice little shortcuts. Did I say those backwards?
I think so.
Yeah, I did. It was a long weekend. Oops. So, please make sure that on 2 and 3 you actually do what it says. Find the intercepts, don't just get the equation. Find the slope and y-intercept, don't just get the equation. Write an equation for a line, passes through this point, parallel to this. As soon as I hear the words parallel and perpendicular, what's the only thing about this equation that I care about? Do I know what the slope is right now? Nope. So you can either say negative a over b, or rearrange it, get it in slope-intercept form. If I subtract 6x, we got negative 4y is negative 6x plus 3. Divide by negative 4. Negative 6 over negative 4 reduces to 3 halves. What's the only thing in there I care about? Just that slope. So I look at this and I say 3 halves is parallel to what? 3 halves. Parallel means same slope. What if it was perpendicular? Opposite reciprocal, yep. Okay. So just make sure you know the difference, whether it asks for parallel or whether it asks for perpendicular. Okay. Now in this case, they want parallel. So I'm going through this point and I'm using this slope. Point slope form? It's a point, it's a slope. It slices, it dices, it does your taxes. Here you go. I have a y as a negative 1, an m is a 3 halves, and an x is a 9. I want you all to take a look at the instructions. Write an equation. Is y plus 1 equals 3 halves x minus 9 an equation?
It is.
Yes. Don't leave it like this. That's not simplified yet. This is an equation. Is 3 halves x, so what's that, negative 27 halves minus another, so minus 31 halves. Is that also correct? Yeah. Could I, 3 halves and 5 negative 3, then negative 3 x and 5 plus 2y is, and 5 by 2, and negative 31, yeah? Right? Okay. So it doesn't matter what form I put it in, I'm right, because it just said to write an equation. Doesn't specify what form. I want you to use this one to, I'm testing if you know the whole parallel perpendicular thing. Beyond that, you use whatever form you're comfortable with. Okay. And then Big Kahuna. Okay. Oh, I thought I got rid of the 6. This is all like part of the same problem.
Yeah, it was 20.
It was 26. Oh.
Negative 27. Not 32.
Oh well. Table shows dash temperature for a car as it drives through the mountains. Y'all, anyone here have the little dash thermometer thing shows up on your center display or anything like that?
Yeah.
Okay, that has been wild to watch all summer. One of the days I was driving, I saw it hit like 113, 115. It was nuts. Like, I get crabby above 70, so I don't like summer. So, as you're headed higher and higher up the hill, the temperature is going to drop. Graph the data with appropriate labels and scale. This is why I said number 8 on that homework. You actually need to graph it because it said freaking graph it. Can you take this data and make an appropriate graph out of it? First thing to determine, what's X and what's Y? Okay, so maybe off to the side, or maybe right next to A, I'm going to write altitude degrees Fahrenheit. So I know what's X, what's Y. Might also help me answer the questions down here. Okay, how do I decide on an appropriate scale?
Probably just yeah.
Probably just yeah.
Yeah.
Okay, so by the wisdom of Rylan, I can now go, and there's my graph.
Yeah.
It doesn't work that way, bud. Doesn't work that way. Look for what is your minimum and maximum values. So for my altitude, what's the lowest that ever went? Highest. So I need to go at least this 4,500 foot range, at least. Okay, there's another part. You notice they're all in thousands. Could I just write in thousands of feet? Save myself some time. Ooh, then I would have to have a 10.4 as one of my points. Could I go by thousands? Could I go by hundreds? Could I leave them as is? All of this is right. You just have to make sure that you say it, that you write it. Okay? Now, so would you rather have a bunch of zeros and leave it as is, or go by thousands and we'll have a 10.4 in there? Oh, wait. Are we going by thousands or hundreds? Okay, by hundreds, because then 75, 82, 86, I heard thousands, so I had, all right. When we get here, if we're going by hundreds, it is still 104. All right. So I'm going to say altitude by 100 feet. So that tells me what my increments are by hundreds. This is one of those where I would recommend we don't actually have to start down at 0.
No, it's not years.
Okay. Can we do that little like lightning bolt thing and start somewhere else?
Can't you just start at 7?
Could I start at 75 itself? Yeah. So I'm going to, well, before I go writing anything on here, what is my scale going to be? What do you want each box to be?
Ooh. So we have to go with the 120.
You've all heard the KISS axiom, right? Keep it simple, stupid. Keep it simple. Maybe if I just started this at 70, right? 70, 80, 90, 100, 110, 120, 130. See, I'm going to fit that 12,000 in there. And I'm going by just nice rounded numbers. It doesn't have to fit perfectly, because might we want this line to keep going and extrapolate an answer? Okay. 140, 150, 160. Okay. So there's our altitude, our temperature. Up to 61, down to we're headed into the 40s. I've got 10 boxes. 66 to 46, that's 20. Yeah, we could fit it on there going by twos. We can go by fives. Tens would probably be a little overkill.
Probably that, yeah.
Okay, fives. Okay. Well, if I go from 0 up 10 boxes and go by fives, that's only 50. Okay. So maybe start at, so I've got 9 boxes by 5 is 45. 20 to 70? Yeah, that works. I like that. 20, 25, 30, 35, 40, 45, 50, 55, 60, 65 fits perfectly. Okay. I mean, would it have been wrong if I started at 30 and went up to 75? No. I just need to fit my data, and I need it to have a scale. You can't just change the scale. Like, you can't say 20, 25, 30, oh wait, this isn't going to work. 40, 50, 60, 70, 80. You can't just change it like that. Okay? Make sure you label on the side. This is temperature in degrees Fahrenheit. It's not enough to just put numbers on there. You can't just say numbers. Okay? Jacob, you want 5?
Probably.
Do you want 5?
Yeah.
Yeah, cool. 5 detentions. I'll talk to Mr. Sire. We'll get in range for you. You just serve them down in the cabin. You'll be good. Okay, Rylan, you want 5? Nah? Oh, bummer, dude. I had like 5 Pop-Tarts in there just with your name on it. The label matters, right? The label matters. So please put the label on there. Maybe put a giant freaking note right next to it that says, don't forget your labels. Okay? That's why the entire make the graph and then is part of this problem, because we have to know how to do that. We've got 1 or 2 seniors in here, juniors. Oh, you would have done the pre-ACT last year. Was it just English and math, or was there also the science section? Wasn't the science section just read? Like, if you know basic science facts, it was just read graphs and read problems. Okay? If you know how to read graphs, you can do the science section. Like, that's it. So that's why this is so important. Okay? Find the line of best fit using, oh wait, I got to put all my data in here. 7,500, plot points, 61, right about, yeah. 8,200 and 58, about meh. 8,600 and 56, meh. 9,200, 53. 9,750. 10,446. And 12,000 question mark. I think that looks about like a line to me. In fact, that looks pretty good. Now find the line of best fit. We did it for 2 days. We had 3 videos. We just did it for our daily quiz. How do I go plugging in a bunch of data? Aw, no one wants to talk to me. How do I put the data in? Yeah! Okay. We'll go to Stat. We'll go to Edit. And we'll start plugging in data. We had, what was it, 7,500? And then, oh, come on, you rats. 7, 5, 0, 0. It takes so long to type it on this laggy piece. 8,200, 8,600. Oh. Now, both. You can type in the values as they are in the table. You just have to know that when you plot it on your graph has a scale of going by hundreds. You could now change what X and Y represent. You can say X is altitude in hundreds of feet. In which case you would not have all of this extra stuff. How do you want to do it? Because it does change what we have as an equation. You want to go by hundreds? Okay. So 75, enter. 82, enter. 86, enter. 92, enter. 97, 97. All right, y'all seeing this? Like, it's not even hitting the other points. Frank! I hate you, Frank! Like, it's not registering my second number at all. Someone read them off to me. 75.
82. 86.
Frank's not that fast, dude.
92. 97.
Okay. 104, right?
Yeah. 120.
But I don't actually want the 120 in there because I don't have a value to go with it, right? My God. I hate this thing. Okay, and then there were temperatures to go with them. Let's see if Frank can keep up. Starting at
61. 58. 56. 53. 50. 46.
God, this thing's trash. Okay. If I want my line of best fit, stat, calculate, linear regression. Make sure you got your right lists. If I'm going to store it, I can variables. The y's, the function y1. Or if you're on TI-84, alpha, trace. Okay, either way, doesn't matter. I just need to store it. The reason I want to store it is because now, come on you. If I have my table set to my ask feature for independent variables, if I turn my stat plot on, I can see this physically. I could zoom to my stats, we said was the easiest way. Frank's going to take his sweet time. Ooh, that's pretty good. Hey, y'all remember when we had those clothes that were fitting 83% of the body? Wasn't too pretty, right? Take a look at this thing. How do I get that correlation coefficient on here again? If I got it 84, it's just in mode. Mode, stat diagnostics on. If not, I have to second my catalog and head all the way down to the D's, right above 0. Come on, Frank, keep up. And I can turn the diagnostics on. And you say, why would I need to do this? Well, now, if I calculate that line, it's not just going to tell me the line. Yeah, come on. Seriously, it takes as long to do a line as it does a logistic last year. This thing is so trash. 99 and change % fit. This is like a fresh tailored suit here. This is someone started wrapping awkward measurement strips around you and made it perfect. Okay? This is glorious. And if I had to, come on, no, don't do that. Stop it, Frank. Bad Frank. Second table. I said second table. Now I can answer the questions on here. It says, find the line of best fit. Okay, we found it. Hopefully you wrote it. Use your model to estimate the temperature when at an altitude of, this exact thing, 12,000 feet. If I just type at 120, Frank. Doop. About 38 degrees. Okay. Now remember, you get a choice of you can either trace the graph out that far, you can go to the table, you can, you have the equation now, you can just plug in 120 for x. Whatever you're going to do. Okay. Sorry, we got to keep fighting through Frank. I'm really sick of Frank. But by my time, you should be able to finish. Okay. What was that? 3, 4, 4, 2, 7, 5, 6, 7, 5. Yeah, you should. Everyone should finish. If you would please. Get them.
Wait, so what would we put for B, C?
Oh, your line. That was our calculate the line. Like that thing that we got. So part B is right down the line. Part C, use your model, and we said it was about 38 degrees. There you go. That's all I need. Okay, you got the rest of the time to work. If you happen to be a slowpoke and this takes you a while and you want to just keep working into lunch, you can. I'll just try to tell the nerds to not be so loud when they come in here. And yeah, go for it. When you're done, please remember before you leave this room to turn in your notes, assignments, and daily quizzes. Just make one big honkin' Algebra 2 pile over here. And then I'll try to go through those this afternoon while the other classes are taking theirs.